what I thought today, Evie, I'm not a battery researcher. I would say that I'm more of a specialist generalist. And I thought about what I could tell you that would help to lead change and engineer change as we go through what is a really disruptive time in electrification and everything else. It's not an easy journey. And if I just share some slides, I thought this might be more useful actually, because it's something we don't share very often, and it's what I've been doing with all the researchers in the UK. So it helps frame some thinking, and it's a very basic model. It's a very old model on change. So I'm just going to refer back to what is Kotter's 8-step process for change, as I'm going to tell you the story of what we've been doing over Faraday for the last 5 years and where it's going next, hopefully. So what this guy said was actually, when you're trying to change something, you need to have something that's really urgent. And I think climate change is one of those things that's gone from being in the background, being niche, to being really urgent. I think we are all becoming much more coalesced on this problem. So what I wanted to show you is, this is a piece of artwork that UKRI has been using to show over the years just how much warmer the planet has got. And we now know we are in a climate crisis. So what we know in the UK and in the world is we have to find solutions. And no solutions to transport are immediately perfect, right? Even horses will give you some emissions. Even walking actually gives you some CO2 equivalent emissions from the fuel that we eat and everything else. But what we do know is, when we look at the breakdown of surface transport, in particular in the UK, we know that actually cars, vans, and heavy goods vehicles, that's what the HGV stands for, make up a really significant proportion of our emissions. So we say, right, well, how do we solve that without bringing the country to a stop? And the answer that we found, looking at doing the analysis, using life cycle analysis from cradle to grave, is it shows us in the UK that if we can switch and transform to a battery electric vehicle from petrol and diesel, we will be somewhere it will have the impact of about 1/3 of a car, of an internal combustion engine car in the UK by 2030. But by 2060, we can improve that research. Through research and engineering, we can improve that life cycle analysis down to perhaps a 10%, maybe even 5% of what an internal combustion engine car today impacts from the climate change. What the UK has done, which is pretty impressive, is we have actually legislated to get to net zero. So what we have done is develop, not only implementing our law that we will be at net zero by 2050, but we've also got these pathways. So this is the pathway for the UK in transport. And you can imagine that Faraday's focus and the program that I run is very much on cars and vans, and very much on the volume side of things, and very much on the manufacturing of those cars. What we could do is we could import vehicles into the UK, battery electric vehicles, and we will, I have no doubt, import from all over the world battery electric vehicles. However, we wanted to also use the UK's expertise in propelling vehicles. We have if you weren't aware, we have a massive motorsport industry in the UK, a massive love of engineering and motorsport. And actually that's why we have automotive manufacturers in the UK, because we can differentiate ourselves as engineers on how well we can help cars feel when you're driving them for consumers. So the question is, why is it so urgent though, from a volume automotive point of view? And that's because somebody did the maths. So the automotive industry was going along through from sort of 2004 onwards to sort of 2016, 17, quite happily reducing emissions. But what happened then is a few things worked together. You had something called Dieselgate, where the authorities realized that car companies were putting vehicles into a really efficient mode using the internal engine internal combustion engine computer. And so we had something called Dieselgate, you may have read about, because those were modes that were never going to be used on an actual road in real life. So Dieselgate happened, but also while the automotive industry was very focused on what CO2 emission regulation was looking like, the UK car companies also realized that they had an even bigger problem. And this red line shows you the regulatory targets. The last three, well, the last two actually, are regulatory targets that the Automotive Council in the UK worked out were what was needed to hit CO2 target of 1.5% from cars. Now, the problem they had was they looked at that and they realized that was not achievable because it's a fleet average. So they realized the best in class at the time was a hybrid Yaris, and that was down at about 75 grams of CO2 per kilometre driven, and they needed an average of their fleets to be 67 grams. Hybrids wouldn't get there. Even those tiny, the smaller end cars weren't going to meet that. And they realized they'd really hit the limit of the technology they could develop through internal combustion engines, and to be able to hit targets like that. And the problem they have is actually they knew they needed to start making those full electric decisions today, because a car company, basically, apart from Tesla, who sells cars and then makes them, all other car companies makes cars and then sells them. And to make profit, they need to have produced the same vehicle, the same architecture for about 10 years. They might facelift it, and they might change the engine, and they might tweak. In fact, it was that computer on the engine that allowed them to produce what looked like new models to their consumers, but actually wasn't. It was just a slight upgrade through some tweaks and some exterior panels or something else being changed to give them some models through that 10-year production. And they were only starting to make profit at the end of year 7, early year 8. So when you then overlay that on that graph, they knew they needed to be full electric far sooner than their own technology flight paths had allowed. So then they also sat down and went, well, how many batteries are we going to need in the UK for the cars we manufacture here? And they realized, this is a graph that shows you in 2022, the UK produces about 2 gigawatt hours a year of batteries up in Sunderland, which is supplies the Nissan Leaf in reality. Even here and now, they realized they were importing well over 50% of their electric batteries. Their batteries for electric vehicles. What then they realized was actually when they could go out to 2030, they could actually ask in the UK and say, well, what are you going to order for 2030? So that is demand forecast, but actually a lot of that is committed. That's not just a forecast that we have randomly worked out. A lot of that is based on car companies saying, well, by 2030 we've already placed orders, or we're intending to go to tender for this amount. And you can see that we're looking at 90 gigawatt hours just in the UK, just for cars and vans. And so the right hand bit of the slide is sort of saying, well, what about eVTOL? Off-highway is massive in the UK in terms of a demand and future demand. We have JCB here, who are looking at electrifying. We have other companies who manufacture here. We have Leyland DAF making goods vehicles, and companies like Teva and Arrival. And then we also have a static storage applications. So all of a sudden you can see a really massive market for cells. And you can see that the UK would obviously want to be far more manufacturing those cells as we stop manufacturing internal combustion engines and that we transition across. And actually that market has to translate to whether we were looking at where the value came from in that market, because it's so different to internal combustion engines. At every level it's different. So if you take heavy goods vehicles, for example, actually they don't tend to make a lot of profit on the sales price of a big HGV. They make the profit on the servicing of the brake pads and the engines and the carburetors and the new filters and everything else. And so actually when you move to full electric, this changes all those models. And even for electric vehicles, which are family cars and everything else, all of a sudden there's a big shift in where you can make your money. And they started to realize that manufacturing packs was important, but most important in terms of cell materials was the cell materials for the cathode. Anode as well, but cathode in particular has the highest value. And so all of a sudden you start to see how to transition away from internal combustion engines from a UK manufacturing point of view starts to get much more complex. But how do you get it to happen? Because it's not an easy thing to do. And what I wanted to sort of help you understand in those last few slides is the urgency. We had a real realization that that moment where we would use an English phrase of the penny dropped, which means like the light, you know, you suddenly get it, you suddenly realize that there's a real urgency about this. This isn't something that's a nice to do. This is something that's going to have to happen. And in the UK, that really came out of, I guess, European regulation and that understanding, that wider understanding of climate change. What then started to happen in that, after that realization, was this coalition. So what I mean by coalition is where you know your actors in the landscape, and they're all of the same mind, and they go, do you know what? Whilst I might have argued against and for keeping internal combustion engines a few years ago, I can't see a way out of this. We really have to change. And then they started to talk about what that vision was for change and why it was happening. So you can see over those last few slides, in 2017, that climate for change really started to gain momentum in the UK. And then we looked at what the vision should be. And the Auto Council, and the Auto Council in the UK is all the UK manufacturing companies. Sorry, now all the companies, because they're global, that manufacture in the UK. So Ford, Tata, Jaguar Land Rover, Nissan, so Japanese, Toyota, Japanese. We have Stellantis, which is also European and US. So what you've got is a load of global companies really coming together as a coalition to work out what the UK manufacturing bases that they had would need to do to change. And they could see that they needed that support from government to transition their platforms so that their manufacturing sites could make electric vehicles rather than engines. They knew they needed to embed that EV supply chain in the UK because of the cost, the value that's in the materials. So if they only manufactured the electric vehicles in the UK and imported everything else, that would cause them to actually lose out on a great deal of value. That on top of post-Brexit, we also have rules of origin requirements to be able to sell to European markets. And 60% of cars manufactured in the UK would be exported to Europe. 80% gets exported around the world, but that's, so 20% of them gets exported around the world, but 60 go into Europe, and vice versa, we import a lot of cars from Europe. They knew they needed to reduce the cost of EVs and to innovate. And so that innovate to drive towards net zero throughout that value chain and through life became really key to them. And they worked out that actually we needed to make sure we could have a vision of how we could R&D together. So this is just some of the UK organisations. We do have far many more in there, but some of those names you might recognise. British Volt, for example, has just signed with one of the big Indonesian companies for supply. So you've got some companies that you may know, may not know, but JCB, Aston Martin, Nissan. We also have companies like Lotus, so some of the Rolls-Royce, Bentley, real niche vehicles, the high-end, really expensive ones. And actually, again, that comes out of our motorsport background, like McLaren and Williams and Delta on there, and Potenza. Those are all motorsport companies doing a lot of that innovation on batteries with Formula One companies and similar. So you can start to see they started to communicate this, and they created the Faraday Battery Challenge to be that, not only that sort of point where they could communicate, but also explain this, and to be a way that they could start to empower action in some of those companies much quicker, because we fund R&D which allows, in a collaborative manner, which allowed bigger and bigger R&D projects to sort of whet the appetite to gain, let companies try and see where they could fit in that new transition. And that's one of the reasons why we have this coalition, this vision, and we have created some of these quick wins. So I'll talk to you a little bit about the Faraday Battery Challenge. So our two main goals actually are around helping UK automotive industry meet its net zero commitments by the required timescale. I think we're all really committed to a 1.5 degree C targets in the UK, particularly for automotive. And the other bit is to prosper from it. And really that's about making sure a lot of our manufacturing it sits in areas in the UK that actually are relatively poor. And so it's making sure that actually it's not just the rich parts of the UK that prosper from it, but it's actually across all of the country, but also again across all social demographics. And that's one of the really important sort of goals of the Faraday Battery Challenge, is to allow women, different races to really perform and be part of this transition and battery engineering and science in the future. So the Faraday Battery Challenge programme sits across 3 pillars. The first is the Faraday Institution, and that's 400, 500 researchers in the UK, very focused on application-led science in batteries, and that's 450 researchers across 22 different universities. And actually it's even where university departments are working together who may not have worked together before, because what they're trying to do is answer some of those questions that manufacturing batteries brings. And so they work hand in glove with industry. Some of it's I guess further back towards pure science, and some of it's more applied. So that, you know, if you're looking at atomic level degradation of battery and the mechanisms involved, such as Professor Claire Gray in Cambridge, then you might be a little bit further away from industry. But if you're in multi-scale modelling, or actually some of your outputs could immediately go into some of the vehicles on the road, and you're working with Williams Formula One, and you're working with Jaguar Land Rover, you'll see some of your results very quickly. We have UK Research and Innovation, where I sit, but I sit at, obviously, as the Faraday Battery Challenge, and we do this we take research from the university benches and bring it through to through the valley of death, through the mid-technology readiness levels. And what we're doing there is really encouraging collaboration between some of our very large companies and some of our spin-outs from universities or small companies, where you'll have really free-thinking, critical thinking, talented individuals that perhaps don't have that real depth of business knowledge and manufacturing knowledge. So you can put them together so that the bigger companies get challenging but exciting innovation, and they gain, you know, how to do some of your accounts, or how to make sure you're meeting environmental regulations, or whatever it might be from those bigger companies as well, and safety in particular is important to us. But the third piece of the pillar of Faraday is into funding mechanisms. So the first two really are funding mechanisms, where we're bringing, you know, different brains together to really work on the problem. The final piece is the UK Battery Industrialisation Centre, and that's a £130 million playground for engineers and scientists in this space. And really what it is a miniature gigafactory. So it's much smaller than a gigafactory, because in a gigafactory you'd have line after line after line, whereas this one is designed to be much more flexible. And what it means is, if I'm looking at building a gigafactory, I've got somewhere where I can come and trial new materials, trial new cells, trial new packs and modules, to see that when I set up my gigafactory, that my new product is going to be a better product than was produced before. You don't want to build a gigafactory to current technologies. You need to be building your gigafactory to the next iteration of technologies. And the industrialization center is somewhere where you can go and confirm those trials, run at full manufacturing rate. I'm from manufacturing, and normally when you put R&D through the line and you do all your trials, that's great, and you can get to where you want to go. but when you run at full speed, that's where it tends to go wrong. And actually that's what the Battery Industrialization Centre provides: big companies, small companies, and places they can work together. And what it means is you can train your staff, you can get your machine set up, you can get everything you need to get set up in advance done and interrogated there. And that's a real advantage. It's a really interesting moment in the UK where you get told by countries like Germany or the US, this is amazing, why is no one else doing this? And it comes from that vision of change. It does come from how we realized we needed to move. So you can see that we also have some cross-cutting elements to Faraday. One is the continuous research into battery requirements and technology trends. The second is equality, diversity, inclusion and skills. I would give my left arm to have as many women, Evie, in science as we do in Indonesia. So one of those things that we're doing is making sure we're role modeling, showing children all the way through to PhDs and onwards that they can come into this industry and have successful careers where they thrive. And also we can do the analysis and understand what skills gigafactories need, what skills science projects need, what skills spin-outs need, and we can help with all of those things. So we do things like provide investor skills into some of our smaller companies, because we know actually if they can pitch better to investors, they're more likely to get private funding, and then we can move there. And what we've done over 5 years is really build an ecosystem. And we have a partner in the Knowledge Transfer Network who you may have come across at Innovate Edge, where actually you can find who you need to find in the UK very quickly. So if you have a specific question, we should be able to get you to someone who knows the answer quicker and in a more coordinated way. But we sit as part of an even wider ecosystem. And the one thing I love about my job, and why I probably describe myself as a generalist specialist, is because we sit in a much wider sort of ecosystem. So we have partnered with our Advanced Propulsion Centre, who their mission is really around industrialization. So they look at the higher TRLs, and they sponsor very big projects, very expensive projects, to get these technologies into vehicles, because automotive is actually a very hard nut to crack at scale, and that's what the Advanced Propulsion Centre is there to do. And they also have the Automotive Transformation Fund industrialization program, and that's investing in the supply chain that I mentioned, in terms of the materials, in terms of all the components that are needed to transform the UK. You've then also got policy on the government side. What's the government doing and how does this all fit together? You've got regulation and standards. Excuse me. And those fit together. Really what you're looking at there is where's government going? What's its long-term strategy? How's it thinking around now a much more complex system than 5 years ago? And what I mean by that is, what are we thinking about in terms of electric vehicle safety? How does it fit into the charging system across the UK, and how's that being brought forward? How does the whole sort of government strategy fit together? And then the regulation and standards is because actually I'm an ex-environmental regulator. It really does, you're always in lag with regulation, however clever you are, but particularly where you've got such a transformation. So keeping your standards body like the British Standards Institute, bringing people together to build knowledge. So we have high standards for health, safety and environment in particular, where we have regulation that's up to date on all elements that should be elements that should be regulated really tightly to make sure that the public remains safe, and as safe as if they were driving internal combustion engines. And this isn't easy. You're trying to catch up 120 years of internal combustion engine development with electrification very quickly. So we have quite a lot of working together there. One of the big challenges, and I'm sure you guys know this, is how to bring investors into batteries. It's a very difficult space for them. It's capital intensive. You don't tend to get profit return very quickly. And so actually helping investors understand the nuances and the opportunities in batteries has been a real labour of love over the years. We really have been working with them so that they start to gain confidence in batteries. And that's because, you know, they worry that batteries are going to become a commodity and it's all going to be very quick and very quickly offshored or into areas where the UK, with its relatively expensive infrastructure, might have a problem. So you can see here, and I'm going to share these slides afterwards, you can see how all of these elements have sort of come together. And it's the central Faraday team that manages and coordinates this and takes this mission forward for the UK. But every element stands alone, stands on its in a really clear space. And that's part of that vision on how we all fit together and work in partnership. And really what we're looking to do is really leap forward the battery performance. And that allows the UK to have this real value add and to be able to have a core competency around batteries that perhaps it wouldn't have had if Faraday hadn't existed. And obviously our goal is to increase sustainability in particular. My goal is to get that LCA for batteries globally right down. Again, we know we don't want to repeat the errors we've made in the past, and that includes everything from mining and how we mine, how we have audit all those supply chains to make sure that there's the social, economic and environmental aspects are really, really well managed all the way through. And then we obviously want increased power density, increased first life, increased temperature operating range, increasing your gravimetric energy density for your range, decreasing the cost, increasing predictability, and also improving safety. So what you're starting to see then is we're empowered, use all that to empower action and to create these quick wins. So this is the collaborative R&D from our competitions from rounds 1 to 4. And you can see actually we really have, that money has gone out competitively across all of the UK. Now it doesn't take into account here the population density. So you can see obviously London and the Southeast and the Midlands have very high population densities in the UK. But you can actually see that we have spread that money out across the UK, even though it's competitive. So it's been the people coming forward with the best projects that have been sponsored. And we have supported 149 organisations in that collaborative R&D. From that, you can see it's everything from academic to very large companies, the JCBs and the Jaguar Land Rovers of this world, but down to, you know, researchers coming out of the Faraday Institution in a spin out. So it's been a very exciting, it's a very dynamic projects working together. So we've been looking at, again, this empowering quick action and these quick wins and embedding the change. This starts to really become around knowledge. So it's really around how you can work together, how you can navigate what feels like an increasingly complex area and how you understand it. And that's really important to us. You can go and have a look at our UK Batteries Network and sign up. And really what they're trying to do there is work out which applications can be grouped together so that cell applications could be marketed to more than one application. So some of those things are very clear in terms of how we can gain advantage. We've been looking at and keeping a close eye on UK deal flows, which is with those investors, who's investing in what, how can we then shape and introduce more of these companies that are looking for investment with investors that are active in the battery space. We have a networking hub that really can get into detail and also meet each other. And we also have that landscape map where you can see all the different companies, not just the funded ones, but all of the companies in the UK which are interested in batteries. And what we really look to do is refine the baseline of that current, what the current state of art is. You know, where are we? How does the UK and what we're working on really compare globally? but also in different applications. And that again is just helping companies really be able to see where their products could fit, where their technologies could support, and equally where maybe they won't, so that they can refine what they're doing and stop if that research isn't going to be successful. And we do that through understanding and really defining what the strategic drivers in each of those sectors are. And we're doing this centrally, so we're bringing knowledge together, but doing it centrally so that we can help others. And then from that, we look at those battery targets. How does it actually start to break down? The high level ones that we started off with 5 years ago really were pretty naive, and now we are becoming much more nuanced in how we help companies really see where they could have a performance improvement over their competitors. And really looking at how we can communicate that. And we do that with some of these high level target summaries, but also battery technology route maps. And you can see those on the Advanced Propulsion Centre website, or the Automotive Transformation, the Aerospace Technology Institute that also hold those, so our partners. I'm not going to go through these, but these are some of the outputs from that analysis, and it's starting to help people. Say you're in volume automotive, you can see how you might then help and work with motorbike companies or performance automotive, or how you might look at energy storage. What you might be in is Formula One, and you might be right up at the top left-hand side of that graph, doing some of the most amazing battery technologies. But all of that just helps form where you might be really successful. And so we have these different areas that we're starting to help organisations really see how they fit into that battery landscape. And these are the roadmaps that I spoke about. And again, you know, we keep these up to date, and it's very much knowledge, bringing forward knowledge, so that actually, you know, if you sit in wet processing and where you think it's going to go, you can see how the driver might be, for example, to dry manufacturing without solvents, and then binderless electrodes and electrolytes. So it's really looking right across what we do. And again, these are online at the Advanced Propulsion Centre. So really trying to build in that change, and we're starting to see it, but we are just getting started. So we are currently applying to the government for a 3-year extension of the Faraday Battery Challenge, and that should take it to over £500 million over 8 years. The UK government will be investing in this space and in Faraday, which is really exciting. And it just helps, again, you know, us understand and give reassurance to investors that this really tricky bit, the lowest bit on this graph, where you have late stage VC or private equity at the 10 million and higher, that's a really tricky moment for companies to actually get funding from private investors. And all of what we're doing is really trying to reassure investors that the opportunities that exist today in batteries with UK companies really are going to get them where they want to go. And then we start to overlay global activity and global investors and working with those too. And that's one of the things that we're hoping to do over the next 3 years is to tie closer our collaborative R&D with investor partners, so that actually the investors invest in the business and we invest in the R&D, and together those companies really do grow into successful entities with a fantastic board of directors who understand really all the aspects of their business, not just the technology, but also the technology that's coming through can really embed. And then I've put a bit here in terms of some of the electrification skills framework. We work with other partners, so this has come together with power electronics, motors and drives, and really trying to work out how we take somebody who might be at the moment working on internal combustion engines and get them across into electric, or, you know, children today wanting to come through this system, be able to come and work in gigafactories or this area. I've mentioned the Battery Challenge Standards Programme very lightly, but if you go onto the British Standards Institute website, the details are below, you can see the 3 first pre-standards they really are. So codes of practice on health, safety and environment for electrode and cell, package and module and vehicle design. And then just finally, this is really the part that is very close to my heart, very close to my background, being an environmental regulator of heavy industry. We talk about sustainability, and it is frustrating and exciting in equal measure how many people want to be sustainable and how few really understand the depth and breadth of what that really means. So this little flow diagram really was to show how much regulation, how much thinking needs to go into something and making it much more sustainable. And that's something that really exciting to see regulators start to get their heads into this game from Europe and the UK, looking at everything from gigafactories and how they operate back through to waste activities, and making sure those working in waste are doing things that are good for the local environment and not dangerous to the public or their neighbours in the meantime. So it's been really exciting to do that. I chair a cross-government group on sustainable batteries, which works with the Department for Transport, the Department for Environment, Food and Agriculture, the Department for Business, the Department for Vehicle Safety, you name it. Pretty much every UK government department in some way can be involved. Even things like revenue and customs have been interested in some of the thinking around blockchain and application to supply chain. So again, this strong collaboration creating these results has been part of this journey. I'm not going to go through these because I'm running out of time and I don't want to go on too much, but really I'll leave you to read some of these, because it's been on every level. It gets very complex, very technical, very quickly, but that overarching vision of how to make this stick as a transition is really part of it. So hopefully that's given you a framework really to help Indonesia think about the way you're going around, what you're doing, how you might work with us, what is hopefully an understanding of the UK. You can see from some of these successes that I've just popped in here that over the past 5 years, we really have transformed our industry. And it's not been because the Faraday Battery Challenge has been brilliant, but it's because actually the entire ecosystem has really wanted to come on this journey with us. And that's my final message. Cotter said one thing. He said that step number 2, forming the powerful coalition, that actually, if you don't have the vast majority of people really wanting a change to happen, it won't happen. So if I have one thing that I'm very proud of, it's just how close we work together in the UK now on batteries and electrification. It's a really exciting time. Thank you very much.